Now let us try to understand the stress components on elemental volume of solid. Now this is a cube, okay. These are the axes on which the cube rests, and this is the origin, x-axis, y-axis and z-axis. Now these planes are the mid planes of the cube, okay. Now, and this is the z mid plane. Why? Because it is perpendicular to z-axis, and this is the y mid plane. Similarly, this is the x mid plane. Okay. Now, identify the centers of faces. These are the centers of the face. Okay. Now this plane is the x plane, and this plane is the y plane, and this plane is the z plane. Okay. Now there are normal stresses acting on each face. It's along the x direction, it is sigma x, and that normal stress along the negative x direction is sigma x. Okay, both are equal in magnitude because the body is under equilibrium. Okay, we have along the z direction sigma z, and another sigma z. We have sigma y and sigma y. Okay, now there are shear stresses. Now if you consider the positive faces are this one, and the front face. Okay, well, the positive faces are the front one, the top one, and the right side one, this one. Okay, so on these face, the point where the stress is acting is this, and this. Okay, on these faces, the positive directions are, one is this and the other two are this. Okay, now let us consider one face at a time, one plane at a time. Consider the x mid plane, and in the x mid plane, which one is the x mid plane here? This is the x mid plane. So if we write this, the x mid plane looks like this. The points on this plane are these. So this should be sigma y, and then sigma z, and sigma z. Okay, so now the positive directions are this one and this one, positive along the positive y-axis and along the positive z-axis. Okay, now if you consider this force, this is the midpoint. Okay, this force is, this is a shear stress. Okay, and to counterbalance this, there should be an equal and opposite shear stress here. Okay, but these two in effect are trying to rotate the member. Okay, like this, right? Okay, now this one should be counterbalanced by a shear stress equal and opposite at this point, and this rotates this in the opposite direction. Come on. Okay. Now we consider the y midplane, which is square here. The points where it is acting are these stresses. This will be sigma x, sigma z, and sigma z. So the point positive directions are this one and this one, and similar to this analogy, this needs to be accompanied by an equal and opposite shear stress here, and these two result in tend to turn the body like this, and this one turn the body in the opposite direction. Okay, so since our body is under equilibrium, these two couples must be equal and opposite. Okay, under this situation, if we consider an axis of symmetry here, our material is being pulled in this direction and in this direction, so the resultant is like this. So this body, this edge contracts and this diagonal expands. The new positions, these are the new positions. Okay. Similarly, in this case, if we want to consider the deformation, it will be like this. Consider the diagonal. The resultant is acting like this and like this. So the extensional force is this, and the extension of the diagonal occurs here, and the contraction occurs here. So this is how the deformed body will look like. And consider the Z midplane, and this is the undeformed. The dotted lines represent the